Hi guys, in this video we're going to be looking at Unit 2 for GCSE Geography, and we're going to be looking at the section on the UK's Evolving Physical Landscape section or topic. And I'm just going to go over one of the features, one of the erosional features, which is cave stack arch or cave arch stack formation. So I'm just going to talk you through this, then I'm going to look a little bit at different types of coastline, and hopefully you'll be a bit more up to date with these processes. So what we've got here is a cave arch and stack formation, forms on a headland, which is characteristic of a discordant coastline, and we'll get to that in a second, what the difference is between discordant and concordant. But if I just run through the formation of a cave arch stack formation on a headland, then you'll be in a good position to answer it in the exam. So any headland starts off with erosion both sides of the headland as the water or the waves come in and they refract around the headland. It's really important to use that terminology. So the waves kind of come into a more shallow area around the headland, and they kind of topple over each other, and they move around the headland and they attack the sides of the headland, both sides of the headland. So these processes are happening on either side of the headland, and we'll see what happens as they kind of merge in the middle. So on either side, any rock formation has generally got some cracks in the side of it, through the layers of the rock, etc. So they are lines of weakness, and those weaknesses will be exploited by the waves, because the waves are often very, very powerful, especially in the winter time when we get very destructive waves. So it starts off with some cracks in the rock, and hydraulic action and abrasion occur on those areas on either side of the coastline. Now, it's really important when you answer an exam question that you tell the examiner what hydraulic action is or what abrasion is. Generally, those two are the two that you need to use most, because they're the two processes of erosion that are having an impact on the coastline or on the rock. So hydraulic action is when air in the cracks gets pushed further in by the water of the waves pushing or breaking onto the rock. So they push in and they break up the rock further or make it much, much weaker. Then the next thing, obviously waves, which have got particles in them, crash against the sides of the headland or the sides of any cliff, and that causes the cliff sides to wear away at the base. So we've got cracks forming and getting wider and wider, and that eventually this will form a cave. So we'll get a cave forming on one side and a cave forming on the other. Now eventually that erosion will occur so much that each of the caves, the two caves, will kind of meet in the middle, and that's where our arches form. So the arch is because we've had erosion on either side of the headland, and those caves have got bigger and bigger to the extent where the two caves have met, and we get this gap, which you can see from my nice little seagull, and then the gap in the middle forms, and we get an arch forming. Now we need to take a break for a second this way and look up what's happening at the top of the cliff, because this is also really important. At the top of the cliff we've got lots and lots of maybe trees and plants, maybe some animals up there. We've got lots of rainfall maybe, and we get sub-aerial processes occurring at the top of the cliff, and this weakens the cliff top even further. Now this weakening of the cliff top eventually allows this top section of the cliff, or lets the top section of the cliff become so weak that it actually collapses. So this is what's happening. We've got erosion at the base of the cliff, and we've got subaerial processes happening at the top of the cliff. Now you must not forget this process, because it will definitely get you full marks. So the arch becomes very, very, very top heavy. The erosional processes, the subaerial processes are happening at the top, and that the top of the arch basically collapses. So when the arch collapses, this leaves a nice tall stack. Okay, so that is our cave arch and stack formation. Now the stack over time will be eroded, and I'm just going to rub this off a little bit. It's basically going to be more eroded at the base as the waves come in and hit the base, so it gets eaten away at the sides, either side, a bit of undercut in either side of that stack, and eventually that will be kind of come top heavy. It will wobble a little bit and it will fall into the sea, and that will leave here, as we can see, a stump, and that's the end process. So we've generally got these 4 or 5 stages, and the stack is eroded at the base, like I said, collapse over time and forms the stump. So that is our formation of cave, arch and stack on a headland. Now I'm just going to go over very quickly concordant coastlines and discordant coastlines because this comes up quite regularly. So a discordant coastline, if you remember, are where the rock types run at angles to the sea. Not always 90 degrees, but maybe more or less 90 degrees. And often we get hard rock, soft rock, hard rock, soft rock, kind of next to each other. And where we've got harder rock, that will stay as a headland, which is we've got here. And the softer rock will be eroded, so we get headland and bay formation. So related, these are the two types of features that we get on a discordant coastline, and that's also quite a common question, is describe and explain the features on a discordant coastline. So discordant, we know what it is, and then I'm not going to go over headland and bay because it's quite straightforward. Headland sticks out because it's more resistant rock, and the bay erodes because it's less resistant rock. So that's on a discordant coastline. And the next type of coastline is a concordant coastline. Now concordant means that the rocks run parallel to the sea. So we've got harder rock maybe at the front, then softer rock, then harder rock. And if we remember, the feature that occurs here is we can get coves forming. Now if we have limestone like we have down in Lulworth Cove, down in Dorset on the Dorset coastline, that is a concordant coastline, that's southern facing coastline. And that is a band of limestone which is quite resistant, and limestone does have joints in it and has cracks in it, and they are lines of weakness, as we said before. So those lines of weakness eventually at some points let the sea in. Once the sea's got through and it's eroded a little bit, behind that is much softer rock. So as soon as the waves get through that little gap or that little line of weakness, it then can kind of exploit the fact that it's now hitting softer rock, and we get that cove formation. And then behind that softer rock and Lulworth Cove, we've also got a layer of chalk, which is a little bit more resistant. So the cove only kind of goes a certain way back along the coastline or back into the coastline, because we've got that hard band of rock, soft band of rock, and a harder band of rock behind. So those are the features, or that is the feature that we can find on a concordant coastline. So hopefully I've covered quite a few features and processes here for erosional processes and features on the coastline.